Okay, so the last three problems on the 4.2 practice 2. Let's take a look at these. So I don't think I want to do all these. I think I'm just going to do the first two, and then I'm going to let you, the last one, I want you to kind of do on your own. Although maybe I'll help you draw a picture at least. So let's see, the first one here, if we've got this parabolic satellite dish, and they want to know the focus is how many inches from the vertex of the cross section of this satellite dish. Okay, so so the x is the variable being squared here. So we're going to fit this to the standard form x minus h squared equals 4p times y minus k. Okay, so if I flip around the left and the right sides, I end up with 1/43 x squared equals y. If I multiply both sides by 43, I get x squared equals 43y. So that's in standard form. So this tells me that h is 0. This tells me that k is 0 because nothing is being subtracted from y and nothing is being subtracted from x. And more importantly, this tells me that 4p equals 43. And remember, p is the distance between the focus and the vertex. And so p is 43/4. And so 43/4 is going to be what, 10.75? I could put it in either as a fraction or a decimal. Shouldn't make any difference. Okay. And then what about this? Okay, this is just an example where we could just use our graphing calculators and graph this function. So we've got this. Let's read the question first here. Ball is thrown into the air. When the ball is thrown into the air, the path that the ball travels is modeled by the parabola y minus 19 equals this horrible decimal times x minus 12 squared. So the ball reaches a maximum height of what? Okay, there's a couple ways we could do this. We wouldn't even really need to graph this, honestly. We can. But this looks like, if I just take this equation okay, and I put it in the right form. I want it in the form x minus h squared equals 4p times y minus k. So really what I've got here then is on the left side, I'll flip this around. On the left side, I've got x minus 12 squared equals, I'm going to divide each side through by this horrible decimal. So on the right side, I'm going to have the quantity y minus 19 times 1 over negative 0.13, blah, blah, blah. Okay, so we can see from that that h is 12, k is 19, and 1 divided by some negative decimal is going to give me back a negative value for 4p, which means p is negative. So this is a vertical parabola because x is being squared, and it opens down. And so we know that the coordinates of the vertex here represent the highest point that the ball hits, right? And so then when they want to know the ball reaches a maximum height of, well, reaches a maximum height of whatever the y value is at this point. Well, the coordinates of the vertex are 12, 19. And so we can see that 19 is the maximum height. Let's put that in. And then they want to know the ball travels how many feet before it hits the ground. Okay, well, we can see here that if to get to the highest point, the ball had to travel an x distance of 12, right? And so that means that it's going to have to travel twice that far to get back to the ground. So it's going to travel 12 feet to get to the vertex and an additional 12 feet to get back to the ground. And so because the x coordinate is 12, answer to part 2 would be 24. Okay, how could we do that graphically? Well, we could do this graphically pretty easily. We're just going to graph the function. So if I isolate y, I'm just going to add 19 to the other side. So I end up with negative 0.131944444444 times the quantity x minus 12 squared plus 19, right? I got to add that 19. Okay, so let's graph this. Let's let our window go from, how about from -2 or -1 out to 25. And I'm just going to go zoom 0. Okay, so there's everything we need, right? That gives us, obviously this, it doesn't make sense for the height to be negative. So this represents where the ball is thrown, and here's where it lands, right? So if we want to find the coordinates of the peak using technology, we could just go second calc maximum. And then remember, we've got to choose a left boundary for the maximum. So there's my left boundary. I got to choose a right boundary. So there's my right boundary. And then I need a guess. There's my guess. And so it tells me, sure enough, that it's trying to tell me it's at 12. So it's at 12.19. And you know, rounded into a couple decimal places, it would be 12. The calculator just made a small numerical error there. It does that sometimes. Maybe I included one too many 4s, or who knows what I did. Actually, shouldn't make any difference. So we can see that there the maximum height is 19. If we want to know how far it went on the ground, I could find the x coordinates of the y, or excuse me, I could find, yeah, the x coordinates of the zeros, or the x intercepts. So here's how we do that. Second calc 0, and then it wants a left boundary. Well, I'm just going to type, I can either trace or I can type in a number manually. I'm just going to say negative, oops, oh darn it, second calc 0. Left boundary, I'm going to just do negative 0.5. And then I'll trace over right boundary. Guess. So not surprisingly, one of my zeros is at x equals, that's telling me 0. Negative 8.43 times 10 to the negative 13. So that's once again the calculator making a small numerical error. I don't know why that always happens, but that scientific notation, that's telling me this is a point, and then we're going to have 12 zeros, and then an 8, and it's negative. So that's trying to say 0. And then, of course, y is 0. Let's find the other one over here. So second calc 0. Left boundary, this time I'm just going to say 23. And for my right boundary, I'll just say 25. And for my guess, I'll say 24. And what do you know? The answer is at 24, 0. So the x-intercepts, or the zeros, where the height was 0, was at x equals 0 and x equals 24. So therefore we get 24 for the distance the ball travels horizontally before it hits the ground. Okay. Last one. Okay, so I'm going to let you do this one, but I'll help you draw the picture. So you can see here that if I put this into standard form, I'm going to get x minus 200 squared equals, I'm going to divide each side by this small fraction, small decimal, and I'm going to get a big number times y minus 62, right? So we've got a situation here where we've got an upward opening parabola, and x is the horizontal distance in feet from the support towers, and y is the height of the cable above the bridge. So what this is modeling is a cable that's being suspended on a bridge. So this is the picture that you would draw. And you can actually just graph this on your calculator once again and find the answers that way if you want to. But the picture would be, here's one support, there's another support, and here's the cable. And there's the bridge. And so it's measuring the height of the cable above the bridge for every value of x. Okay? And we want to know where's the lowest point on the cable, which is just going to be at the vertex, right? So not a real difficult question, because we can find the vertex pretty easily. Coordinates are 200, and then k is 62. So we can already see that the coordinates of that are, and at the lowest point, the cable is, looks like it's 62 feet. I guess I did do it, 62 feet above the bridge. Okay? All right. And if you want to, you can graph that and use your calculator.